Hello everyone, welcome to the learning field. This is Chandan with you. Okay, so in this video we are going to discuss a very important topic, which is the diagonally dominant matrix of numerical methods. Okay, so this term diagonally dominant is very important and related with the convergence of iterative method. That is, in numerical analysis we must read the Gauss-Seidel method or Gauss-Jacobi method. Okay, so basically these two are most important iterative method when we solve the system Ax equal to b numerically. Okay, you can also say that this topic is related with more general term of this topic or this content is numerical linear algebra. Okay, so this is a linear algebra concept as well as a numerical methods concept, you can say, because when this system Ax equal to b are very higher dimension. Okay, that is, if suppose Ax equal to b, suppose X is an 100 cross 100 matrix or many more order. Okay, then we should go with the numerical methods, the programmings and so on. So now this diagonal dominance is important. I think you should understand the importance of the diagonally dominant matrix. Now what is its importance we come to at the last of this video. So first we see the definition of this diagonally dominant matrix with examples. Okay, see, for a square matrix A, suppose n by n, if for each row the absolute value of the diagonal element is greater than or equal to the sum of the absolute values of rest of the elements, that is the non-diagonal elements of that row, then the matrix A is called a diagonally dominant matrix. Okay, now I think you should understand. Now if we take the matrix, suppose A equal to, if we take a 3 by 3 matrix, A11, A12, A13, A21, A22, A23, A31, A33, A32, A33. Okay, fine. Now what is the definition means? So the definitions means that for A11, the modulus value of the first row, for each row, for suppose first row, this value is greater or equal to the remaining others, A12 plus mod of A13. See, this is the definition of diagonal elements. This is for the first row, for each row. Okay, then the next diagonal element is this one, A12, that is modulus of A22 is greater or equal to A21 plus A23, and these are also the absolute value. Then for the third row, A33 is greater or equal to mod of A31 plus A32. Okay, now generally we write this is mod of AII is greater or equal to summation of j equal to 1 to n j not equal to I modulus of Aij. Fine. So this is the definition of the diagonally dominant matrix. Okay, now one terms you also can relate with the strictly diagonally dominant. Okay, strictly diagonally dominant matrix. Okay, so I think you all clear that the strictly diagonal means the equality sign not occur here. That is, mod of AII is strictly greater than summation j equal to 1 to n and j not equal to I modulus of Aij for all I. For all I and j, that is for each row. Here also for all I and j. Okay, so I think this is the example, or I think you will understand what is the diagonally dominant matrix. Now if we take an example first, just a second. If we take an example, I just remove this. If we take the example, suppose the matrix is A equal to, suppose 15, 6, minus 7, 12, 2, minus 4 minus 2, then 3 2 6, 3 minus 2 6. Suppose this is a matrix, so check whether this is diagonally dominant or not. So first element in the diagonal is 15, that is we check whether mod 15 is greater equal to sum of these two or not. So mod of 6 plus mod of minus 7, this is equal to 6 plus 7 means 13, that is mod of 15 is obviously greater or equal to, we can say, mod of 6 plus mod of minus 7. Okay, now we have to check for each row. Okay, for each row. Okay, so this will occur for each row. Then we said only the matrix is diagonally dominant. Now mod of minus 4, this is equal to 4, and then mod of 2 plus mod of minus 2, this is again 4, that is mod of minus 4 is greater or equal to mod of 2 plus mod of minus 2. This is also hold for first row, for second row, and for third row. We can also check that mod of 6 is strictly greater than or equal to mod of 3 plus mod of minus 2. That is, this is also holds for the third row. This element is strictly strictly greater or equal to the sum of the other two elements of that row. So this matrix is a this matrix is a diagonally dominant matrix. Now if we take another example, suppose for B this matrix is equal to 15, then 6, then 9, then 2, then minus 4, then minus 2, then 3, then minus 2, then 5. If we take another example, this is also, you can say, this is equality, and this is also equality, and this is also equality. That is, for all these three row, mod of aii is greater equal to or equal to the remaining others. Mod of aij, summation j equal to 1 to 3, j not equal to I. Okay, this is holds. That is, if this the diagonal element, if the absolute value of the diagonal element is equal to the absolute value, sum of absolute values of the remaining other two entries, that is the non-diagonal entries, then also we can say this is diagonally dominant. But for strictly diagonally dominant, we should check that this element is strictly greater than or not. So suppose this is 15, 4, 6, this is 6, 1, minus 3, this is 2, 5, 8. See, this 15 is greater than, modulus of 15 is greater than mod 4 plus mod 6, then 6 is greater than, strictly greater than 3 minus 3 plus 1, then this 8 is also greater than 2 plus 5. So see, these all three cases, the elements, diagonal elements is strictly greater than the absolute sum of absolute values of remaining two elements. That is, this matrix we can say the strictly diagonally dominant. Okay. Now if we take also another example to check whether it is diagonally dominant or not. See, I take three different examples for three different cases: diagonally dominant, then strictly diagonally dominant. Now if we take an example, 25 to 4, then 36 minus 3 minus 9, then minus suppose 100 minus 90 minus 9. Okay, now for the first row, 25 is obviously greater than 2 plus 4. Fine, this is fine. Now this 3, mod of minus 3 is greater than mod of 36 plus mod of 9. No, this does not holds. Okay, this is not hold. Then mod of 9, minus of 9 is greater than mod of 100 minus 100 plus mod of minus 90. This also does not hold. That is, this matrix, suppose A, this is not a diagonally dominant matrix. Okay, now the importance of this diagonally dominant matrix. See, when you have questions regarding the convergence of iterative methods. Okay, so this is a sufficient condition that if the matrix, suppose Ax equal to B is a system. Okay, if the matrix, and A is obviously a square matrix, if the matrix is strictly diagonally dominant, then the Gauss Seidel or Gauss Jacobi, or simply Jacobi. This method also, some books says only Jacobi method. Iterative methods are convergent for any initial vector. That means, you see, sometimes in GATE exam you have questions, right? Suppose u equal to, you have given 0 0 0, then find the second iteration, find the third iteration using this Gauss Seidel method or Gauss Jacobi method. Or sometimes you see the questions in NET 2024 CSIR जुलाई 2024 में क्वेश्चंस आया था. Here 4 matrix given and you have checked whether this system Ax equal to B or Gauss Seidel method is convergent or no. Okay, just 2 by 2 matrix था in the exam paper. Suppose 3 minus 3 2 2 3 ऐसा कुछ matrix था. ठीक है, ऐसा करके 4 matrix था. And see, very simple questions in 4.75 marks. Okay, see this matrix, suppose this is the one form, so minus 3 is greater than 2 and 3 here, this diagonal 3 is greater than again 2. So see, this matrix is strictly diagonally dominant matrix and hence the Gauss Seidel iterative method is convergent. So see, what is the importance of this method or the diagonally dominant matrix? If the matrix is diagonally dominant, then the Gauss Seidel iterative methods are convergent for any initial arbitrary or for any arbitrary initial vector. Okay, so this type of questions, then in the GATE exam you will get these types of questions, very common questions. Suppose you have u0 then find the iteration of Gauss Seidel method or Gauss Jacobi method. Suppose you have option in the 4 options that this method does not converge or the method does not converge. So you will have to first check that whether these methods are convergent or not, and this is very tricky and very shortcut method to check whether the Gauss Seidel method or the Gauss Jacobi method are convergent or not, because whether this method, since whether these methods are not convergent, then we can't solve this system. We can't solve this system if the methods, iterative methods, does not convergent. So I think you will understand the importance of this diagonally dominant matrix, that you can just 3 or 4 seconds or 10 seconds or 20 seconds to check that the system is convergent or not. So I think you will understand. So you will understand, then definitely do comments in the comment section below, and if this video is helpful for you, then obviously give a like to this video and share with your friends. And our next target is 10k subscribers, so subscribe the channel more and more and share more and more to achieve 10k subscriber as soon as fast. Okay, so thank you and see you again in the next video. Bye.